You came here because the title touched something in you. A quiet, familiar pull you felt every time the universe does something it shouldn't. You've lived long enough to know the sky rarely gives us surprises that matter. But when it does, it's worth pausing for. And tonight, the newest images of 3i Atlas are exactly that kind of moment. They aren't rumors. They aren't recycled headlines. They're fresh frames, less than 2 days old, captured from 3 continents and multiple spacecraft. And when you look at them closely, really closely, you realize they don't just challenge one part of comet physics. They challenge nearly all of it. You click on a video like this because you want calm truth, not noise. You want someone to walk you through the strangeness without trying to sell you a fantasy. You want to understand what the data actually shows, what these jets look like, how the dust behaves, why the symmetry is so sharp, and why astronomers who normally disagree on everything are suddenly leaning in the same direction. Something about 3i Atlas is behaving in a way no known comet should. You're not here for fear. You're here for clarity, for wonder, for that steady, late-night voice that says, "Let me show you what's real." So let's start with what the images reveal in the simplest terms possible. The newest frames show 3 dominant jets streaming from the object, but these jets do not fan out like natural outgassing. One glows forward, directly toward the observer, with a deep red tint that holds steady across multiple exposures. Another extends backward, thin, blue, razor straight, cutting across the background stars with almost impossible clarity. A third faint column emerges at an angle, forming a pattern that repeats itself from image to image, as if anchored to fixed points on the surface. In natural comets, jets twist, flicker, and sweep as the nucleus rotates. But here, something different is happening. The jets keep their directions even as the entire object turns. And that is the detail that has drawn nearly every pair of eyes in the astronomy community. Rotation should cause sweeping motion, like a lighthouse beam drifting across a dark sea. But 3i Atlas doesn't sweep. It turns, and the jets simply ignore the turn. They stay locked in place. You can scroll through the frames in sequence and feel a kind of quiet dissonance building inside you. Your mind knows how comets behave, but your eyes are telling you something else, something organized, something patterned, something that looks, in the most literal sense of the word, structured. You're here because you want to know what that structure is. You want to understand why the dust forms thin ribs instead of clouds, why the brightness pulses in a regular rhythm, why the object's silhouette looks sharper than any interstellar visitor we've recorded. You want someone to explain it without jumping to conclusions, without hiding behind jargon, and without dismissing your intuition. Because your intuition is right. There is something different in these images, and ignoring that difference would be unscientific. So tonight, you'll unwind while exploring a mystery. You'll hear what the frames show, what the data implies, and why these signatures don't match the physics comet models rely on. You'll learn how the jets behave, why the symmetry matters, and what makes this rotation so unusual. You'll see why the past 48 hours have sparked the most focused attention on an interstellar object since the first photographs of Oumuamua. And through it all, you'll stay grounded, calm, steady, curious, because that's the only way to approach something like this. You're not here for a conclusion. You're here for understanding, for that gentle, late-night space where your mind can stretch without strain, where questions feel bigger than the day you just lived, where the universe reminds you that it still has the ability to surprise you. The images are real. The structure is real. And by the time this journey opens up, you'll understand why so many astronomers believe these frames may mark a turning point in how we study objects from beyond our sun. When you lean back and let your breath settle, the story of 3I Atlas begins to feel less like breaking news and more like a long, slow ripple that has been crossing space for millions of years before finally touching you here tonight. To understand why the newest images matter so deeply, you need a gentle step backward into the quiet origins of this visitor and into the subtle clues it has been giving us since the moment it entered our sky. You first heard its name alongside two others that changed astronomy forever, Oumuamua in 2017 and Borisov in 2019. Those were the first two confirmed interstellar objects ever detected, tiny, fast, fleeting guests passing through our solar system on open-ended hyperbolic paths. Atlas became the third, but unlike its predecessors, it was big, much bigger. Early modeling suggested a diameter of at least 5 kilometers, making it thousands of times more massive than Oumuamua, and perhaps the largest interstellar object ever observed by human eyes. That alone would have made it notable. Large bodies from beyond our sun are rare, and when they appear, they usually behave like oversized comets, dusty, chaotic, unpredictable. Atlas did not. From its earliest detections in late summer, astronomers noticed the object's brightness fluctuating more strongly than expected. Not random flickering, but a soft pulse. Bright, dim, bright, almost rhythmic, as if the object were turning a reflective surface toward us and then away again. Its trajectory added another layer of curiosity. Instead of sweeping down from above or below the ecliptic plane, like most interstellar wanderers, Atlas approached on a retrograde path unusually close to the plane of the planets, as though threading a needle through our system's natural geometry. These details didn't raise alarms, but they did raise eyebrows. Then came September, and with it, the first signs that Atlas was not going to follow the familiar script of a comet nearing the sun. Telescopes detected a plume of CO2, but the direction was wrong. Instead of streaming away from the sun, where heating is strongest, the plume pointed toward it, a behavior rarely seen, and never with the intensity recorded here. Observers waited for the plume to broaden or twist, as solar pressure usually forces material outward, but instead, the plume sharpened. The tail that should have formed behind Atlas began to fade, and over the span of a few nights, what should have become a wide, dusty fan transformed into a compact glow, hugging tightly around the nucleus. By early October, the tail had vanished entirely. In its place appeared a soft halo, almost perfectly symmetrical, a shimmering globe of light with subtle gradients, more like a distant nebula than an energized comet. Symmetry like this is exceedingly uncommon. Dust is messy, thermal vents are uneven, rotation smears features across space. Yet here was Atlas, wrapped in a glow so balanced that even veteran observers paused. It wasn't dramatic. It wasn't loud. But it was unmistakably strange. As Avi Loeb remarked, symmetry is rarely accidental. Around this time, the brightness pulses became more patterned. Not a metronome, nothing so precise, but enough to make analysts compare frames with quiet curiosity. Was the pulse caused by rotation? By internal shadowing? By jets we could not yet see? Each possibility seemed reasonable enough that no one pressed the issue. Every anomaly still had a natural explanation, waiting somewhere in the wings. And so, the story of Atlas continued to unfold gently, like a book being opened page by page. Yet one anomaly lingered longer than expected: the potential for non-gravitational acceleration. Most comet-like objects experience slight nudges caused by jets of gas pushing off the surface. But early estimates suggested the push from Atlas might be stronger than what its visible activity could justify. Nothing conclusive. Just enough to make people wonder. Combine that with its rotation. Fast enough to distort dust patterns, but not fast enough to tear the object apart. And you had the beginnings of a puzzle. Not a crisis. Not a revelation. Just a whisper that things might not be entirely ordinary. And through all of this, you could almost feel the patience of the night sky itself. The dark stays quiet. Stars do not rush. Light reaches you when it's ready. Observing an object like Atlas requires the same stillness. You watch slowly. You compare carefully. You let data arrive in its own time. And as you follow the patterns, your own thoughts begin to settle. This is why you come to videos like this. Not for urgency, but for the gentle rhythm of understanding. For a moment of peace shaped by curiosity. By mid-November, the picture of Atlas was clear in one respect. It was strange, but everything strange still made a certain kind of sense. A plume pointing the wrong way could be explained by uneven heating. A vanished tail could be explained by angle and timing. A symmetrical glow could be dismissed as a photographic artifact or a brief period of unusual stability. Every anomaly made sense until the new images arrived. And then, the sky gave us something new. You don't expect the universe to present you with straight lines. You don't expect directionality, stability, or order when an object made of ice and dust races past the sun at tens of kilometers per second. You expect chaos. You expect the randomness of heating, the unevenness of surface vents, the turbulence of particles pushed by solar wind. That's what comets do. That's what nature does. And that's why the newest images of 3I Atlas felt, to so many astronomers, like a quiet electric shock. In the last 48 hours, the jets coming from Atlas didn't just brighten. They clarified. They sharpened. They revealed themselves with a confidence that left almost no room for misinterpretation. What used to look like a loose haze became a set of defined streams. Multiple jets extending from the nucleus in distinct directions, each holding its angle across repeated exposures. The widening spread we normally expect from gas expanding into vacuum simply wasn't there. Instead, the jets seemed to emerge along fixed axes, almost like beams shining through the dark. The first of these was the red forward jet. Observers noticed it even before the official processing began. In raw frames, a subtle red glow extended toward the observer, almost forming a thin spear of light. After calibration, the jet remained. No matter which observatory captured the frame, no matter the angle of the background star field, the jet held its orientation. This consistency should have dissolved with rotation or particle drift. Instead, It persisted like a feature pinned to a rigid axis. Opposite it, a second jet revealed a deep, cool blue tint, stretching backward with a near mathematical straightness. The color difference puzzled observers immediately. Different wavelengths don't usually segregate like this unless there's a very specific composition and energy profile behind them. Yet here were two jets, pointing in precisely opposite directions, stable across tens of observations, behaving like paired signatures rather than chaotic eruptions. When researchers overlaid the frames into a time lapse, the pattern repeated as if following choreography. And then, as more images streamed in, smaller dust columns became visible, thin, sharp, aligned. These were not the wide, smeared trails familiar from comet photography. They looked more like etched lines, faint but unmistakable, stretching outward as if dust particles had been arranged along straight paths rather than thrown into open space. This was the moment when many astronomers stopped treating Atlas as a quirky interstellar comet and started wondering what exactly they were looking at. Everything pointed toward a kind of organization no one expected. As one observer remarked, symmetry where chaos should be. And that symmetry only deepened as the hours passed. One of the most surprising developments was the strengthening of the anti-tail. Even in normal comets, an anti-tail can appear when dust grains form a sheet that aligns with the orbital plane and is viewed from certain angles. But those features tend to be broad, diffuse, and heavily dependent on perspective. Atlas's anti-tail broke all of these expectations. It did not blur. It sharpened. It stretched like a clean blade of light, gaining definition as though the dust grains were not scattering but aligning. No one had seen an anti-tail behave with this level of stability. It was as if the object were emitting material along a controlled plane. Equally astonishing was what wasn't happening. There was no sign of fragmenting. Large comets nearing the sun often begin to shed pieces, crack along thermal lines, or dissolve into multiple cores. Atlas, despite its mass and unusual activity, showed none of these features. No secondary fragments, no bright flares from surface breakage. Its nucleus remained smooth, consistent, and, most baffling of all, sharply outlined against its own coma. Interstellar objects should be fragile. This one appeared anything but. Brightness fluctuations added a new layer to the puzzle. Instead of random changes triggered by outgassing, the surges followed a gentle rhythm, almost synchronized with Atlas's rotation. Observers comparing 12-hour intervals reported a soft pulse, brightening as one jet angled toward the sun, dimming as it pulled away. This is normal behavior for venting material, but the consistency and clarity of the pulse were not. The light curve had structure, almost like a repeating signal written into Atlas's spin. Dust behavior pushed the mystery even further. In almost every frame, the dust particles followed straight paths outward, not curves, not spirals, straight paths. This is profoundly unusual. Dust grains are tiny, easily perturbed, and influenced by every form of solar pressure. But here they formed lines, tracks, lanes, as if each grain had been launched along a fixed trajectory. When analysts mapped these paths, they discovered that several aligned perfectly with the primary jets, reinforcing the impression that the object was not behaving like a random emitter, but something coordinated. This is where the emotional weight settles in. You're not just looking at a bright spot anymore. You're looking at behavior, at intention, not in the sense of purpose, but in the sense of repeatable patterns that do not arise from noise. And standing in that recognition feels like stepping into a moment that humanity may remember. The first time we recorded an interstellar object that didn't just break rules, but quietly, elegantly stood apart from those rules. The sensation is not fear. It's awe, a measured, grounding awe. A sense that you're witnessing something for the very first time, something the sky hasn't shown us before. When Loeb said, "Nature doesn't usually build straight lines," he wasn't making a claim. He was stating a fact. Physics loves gradients, curves, diffusion. Atlas, through these newest images, seems to favor alignment, precision, a level of order that no natural comet has displayed so consistently. This isn't about jumping to conclusions. You will hear no sensational claims here. What you are seeing in these images, and what you're hearing tonight, is simply the truth as captured by dozens of telescopes. Jets, fixed in orientation. Dust, aligned in lanes. A bright red axis and a blue counter-axis. A symmetric glow that refuses to collapse. An anti-tail that sharpens instead of fading. And an object that shows no sign of breaking apart despite the enormous stresses it now experiences. You're witnessing an anomaly, one of the largest since the discovery of Oumuamua. But unlike that fast-moving traveler, Atlas is giving us more time, more light, more structure to study. And what we've seen in the last 48 hours hints that whatever is happening is not a momentary fluke. The structure holds. The patterns repeat. This is not something flickering into existence and fading away. This is something maintaining itself in the harshest environment a comet can face. And that realization changes everything. It reframes the last 3 months. It reframes the anomalies we once dismissed. It reframes the way we think about interstellar visitors. Because this wasn't just a comet behaving strangely. It was something preparing us, quietly, steadily, for the images we now have. But the real mystery appeared when we studied how Atlas rotates. When you follow an object in the sky long enough, you begin to sense its rhythm. Most comets spin slowly, taking anywhere from 10 to 24 hours to rotate fully. Their dust clouds drift accordingly. Their jets sweep in wide arcs. Their shapes shift gently over the course of a night. But when the newest images of 3i Atlas were aligned side by side, something immediately stood out to every observer watching the sequence with patient eyes. The rhythm was wrong. Atlas wasn't turning like a comet. It was turning like something else entirely. The frames taken minutes apart, 3 minutes, 5 minutes, 7 minutes, showed dramatic changes in shape. Not subtle brightening or slight asymmetry, but real, visible transformation. The bright halo that once looked symmetrical stretched outward, then compressed. The faint dust lanes shifted angle. A small protrusion on the red axis grew longer, then faded. A blue streak sharpened, then softened. These were not the changes you'd expect over hours of rotation. They were happening in the time it takes to refill a coffee mug. And yet nothing about the motion seemed chaotic. This is where the puzzle deepens. Because if Atlas truly rotates this quickly, its dust cloud should be a swirling mess. Fast rotation tends to scatter particles. It destabilizes weak structures. It generates turbulence that blurs all features. But Atlas defied that expectation. It turned, and the dust responded, but the response was subtle. You could see the canted bend of dust arcs, the slight curvature that comes when rotation gently pulls material outward. You could see the faint sweeping effect, like the slow movement of a paintbrush across a dark canvas. But nothing ever broke into disorder. Nothing smeared beyond recognition. Rotation was happening. It was just neat. Astronomers comparing the frames noticed that the sweeping effect itself followed a pattern. The dust would bow outward slightly and then return, as though the particles were being guided by something beneath the surface. A typical comet produces multiple vents that fire unpredictably depending on the sun's heat. Atlas seemed to operate with a far more consistent rhythm. The sweeping was there, but refined, almost elegant. Even the glow around the nucleus expanded and shrank in a steady pulse, brightening when one axis faced the sun and dimming when it turned away. But as smooth as the rotation seemed, an even stranger detail hovered beneath the images like a quiet question. The jets didn't appear to care. In every expected model of comet behavior, jets respond directly to rotation. They pivot, they trace arcs, they sweep like the hands of a clock. Here, they didn't. The red jet toward the front held its exact orientation. The blue jet behind it stayed locked in place, as though the object's spin carried no influence at all. In the time-lapse sequences, the body rotated, the dust shifted, but the jets remained fixed, as if emerging from axes independent of the comet's spin. This is precisely the kind of detail that makes seasoned scientists pause longer than newcomers. After all, nature is consistent. Gases follow rotation. Dust follows rotation. Heat flows across a turning surface. When something doesn't follow the rules, it signals one of two things. Either we misunderstand the object's shape, or the object's behavior is unlike anything we have modeled. And that second possibility carries weight. Even the brightness fluctuations mirrored the rotation in a way that felt almost too synchronized. Atlas brightened softly at predictable points in its turn, like a lighthouse beam rotating past your line of sight. But unlike a lighthouse, the core didn't flare or spike or flicker. It glowed steadily, pulsing with a pattern that matched the rotation angle almost perfectly. This meant the object's changing light was not simply reactive, it was structural. Something about the way Atlas held itself in space caused the glow to rise and fall in a repeating rhythm. The result is a paradox. You have a body spinning far faster than expected, yet not shedding fragments. You have dust lanes reacting to rotation, yet arranging themselves along straight lines that no natural turbulence should produce. You have a brightness profile that matches a rotation curve, yet shows an order almost too clean for an object exposed to solar heating. And you have jets, those powerful streams of expelled material that appear completely indifferent to the object's spin. This is where the fascination begins, because as you listen, you start to sense the same internal question that astronomers have been whispering to one another for the past 2 days. Why do the jets ignore the rotation? Why do they maintain direction even as the entire nucleus turns beneath them? Why does the dust dance according to the rules, while the jets behave as if those rules don't exist at all? Loeb phrased it with his usual precision. The jets behave as if rotation doesn't matter. And while it's a simple sentence, it cuts to the heart of the mystery. If rotation cannot explain the behavior, something else must. Something more complex, something more structured, something we haven't yet named. And that is why this part of the story matters so much. Rotation should have simplified the puzzle. Instead, it made the puzzle harder. It set the stage for the biggest revelation in the new images. Because if you want to understand what Atlas truly is, or at least what it is not, you have to understand the jets. The rotation anomaly is the doorway. The jets are what lies on the other side. And when we finally examine the jets themselves, everything changed. If you've been following the story of 3i Atlas up to this point, you've already seen anomalies. Rotation that moves too quickly, dust lanes too straight for comfort, a glow too even for a natural comet. But nothing prepared astronomers for what they saw when they examined the jets closely. These jets are the heart of the mystery. They are the reason so many experienced observers have paused, stared at their screens longer than usual, and whispered the same quiet question: what exactly am I looking at? Because these jets do not behave the way jets are supposed to behave. In fact, almost every rule we apply to cometary activity seems to crumble the moment you compare the last 72 hours of Atlas data to what our models predict. The first and most shocking detail is something you already sensed in the previous section. The jets don't rotate, not even slightly. You can watch the nucleus turn in the time-lapse footage. Dust shifts, the halo pulses, tiny arcs bend and straighten. But these jets hold their orientation with absolute indifference. They don't sweep. They don't wobble. They don't drift. They stay perfectly aligned with their axes as though the object's spin has no influence on them at all. Natural vents, erupting gas and dust simply do not behave this way. Rotation always leaves a signature. Always. Yet here, you see none. Instead, the jets aim in exact, stable directions, almost like beams, or pillars rather than clouds of dissipating particles. It's the kind of detail that forces you to lean closer, adjust your brightness, and make sure you're seeing real data and not an artifact. But the more images you compare, the clearer it becomes. The jets are fixed. They refuse to obey the spin of the body they emerge from. That alone would raise eyebrows. But the direction of one jet deepens the mystery even further. One of the most prominent jets, the one that glows with a red-magenta intensity, points toward the sun. This is exceedingly rare. Comets erupt outward, away from the sun's heat, because gas expands as ice vaporizes. Venting toward the sun is possible, but usually weak, turbulent, and short-lived. But on Atlas, the sunward jet isn't weak. It's one of the strongest. And not only does it exist, it remains arrow-straight, anchored to the same axis, even as solar wind pushes against it. This is not chaotic outgassing. Chaos bends. Chaos disperses. Chaos softens edges and moves with pressure. The Atlas jets do none of those things. They hold their lines. They define their shapes. They almost appear confident. Then comes the observation that sent analysts into days of debate. Each jet has a different color. Not subtle. Not a slight tint. A clear difference in spectral signature. The red forward jet maintains its warm hue across every instrument that captured it. The blue backward jet stays cool, sharp, narrow, almost icy in tone. Even the fainter columns emerging at angles reveal their own unique spectral fingerprints. Different colors suggest different materials. Different materials suggest different vent origins. And different vent origins, structured in repeating patterns, suggest something more complicated than naturally distributed surface fractures. When analysts compared the positions of the jets frame by frame, they discovered something even stranger. The angles between them stayed consistent. No matter how the nucleus rotated, each jet emerged along the same geometry. It was as if the vents themselves formed a pattern. 3 or 4 points organized around the object's surface in a way that felt more like the geometry of a system than the spontaneous formation of natural cracks. Jets normally erupt where heat hits vulnerable surfaces. On Atlas, the jets erupt along axes that appear evenly spaced, deliberately aligned, almost architectural in their arrangement. And then there is the narrowness. Jets from comets normally widen as they travel, spreading into space like a fan of mist illuminated by sunlight. The Atlas jets remain narrow far longer than expected. For tens of thousands of kilometers, they hold their thread-like shape before finally beginning to diffuse. The dust columns attached to them behave like lanes, straight, crisp, almost etched. That stability has no easy explanation. It implies a consistency of flow, a uniformity of material, and a lack of turbulence that natural comets simply cannot provide. The twist came when observers realized the jets had remained stable not for minutes or hours, but for 3 consecutive days. 72 hours of fixed geometry. 72 hours of unchanged angles. 72 hours of straight lines emerging from a rotating, heating, accelerating body, traveling through a region of space where even the gentlest solar wind should disrupt symmetry. And yet, the symmetry held, night after night, frame after frame. This is where the emotional weight settles in. Not fear, but the sensation of witnessing something profoundly unfamiliar. The feeling that you're seeing a phenomenon that belongs to a category we do not yet have words for. Something too clean, too consistent, too organized to fit inside our current understanding of how natural jets behave. When you step back and let the full picture settle over you, the conclusion is simple. You are watching physics behave in a way that does not match the models, not break them with violence or drama, just quietly refuse to follow the rules. This is why the jets matter. They are not a footnote. They are the focal point of the newest images. They are the anomaly that ties the others together. Dust lanes don't become straight by accident. Symmetry doesn't hold by luck. Rotation doesn't spare jets unless something unusual is shaping their behavior. And as Loeb said when asked about the images, it's a jet, but not one we understand. So what exactly are we looking at? When you step back from the individual anomalies, the fast rotation, the straight dust lanes, the unwavering jets, you begin to see something larger, something that doesn't reveal itself when you analyze each detail in isolation. It's only when you hold all the frames together, like pages from a cosmic journal, that the full shape of the mystery begins to surface. The newest images don't just show activity. They show arrangement. They show pattern. They show behavior that looks, in a quiet and unmistakable way, organized. The first clue comes from the fixed vent points. In almost every frame collected over the last several days, The jets emerge from the same exact locations on the nucleus. This alone is unusual. Surface heating on an object like Atlas should shift as the rotation brings new regions into sunlight. Different spots warm, vent briefly, then cool again. But Atlas doesn't cycle its venting. It repeats it. The jets anchor themselves to the same points, rotation after rotation, night after night. The red forward axis, the blue backward axis, two fainter ones at precise angles. The geometry doesn't drift, blur, or break. It simply stays. Then you notice how the dust lanes behave in relation to those jets. Dust should scatter, curving outward under solar wind pressure. Instead, the dust forms long, clean lines that intersect with one another at predictable angles. When analysts overlaid the dust lanes from multiple nights, they found that the paths crossed along the same geometric grid, lines converging like the spokes of a wheel or the ribs of an unseen structure beneath the glow. The dust wasn't just venting. It was responding to a pattern written into the object itself. This is where the word structure begins to feel appropriate, not because anyone believes Atlas is built, not because the pattern implies intention, but because the data consistently points toward repeated behaviors emerging from stable features. When the jets align with one another in perfect opposition, when the dust lanes intersect along fixed angles, when the glow forms a symmetric envelope around the nucleus, you're no longer looking at random outgassing. You're seeing a system, and over multiple days, that system refuses to collapse. One of the most striking things about the newest observations is how little the symmetry changes. You would expect solar heating to disrupt the balance, warping one side more than the other, or creating turbulence in the dust cloud. But night after night, the jets rise from the same points, maintaining their colors and their angles. The dust traces the same tracks. The anti-tail keeps its knife-like shape. Even the brightness pulse stays steady, as if following a metronome built into the object. This is why so many astronomers have started using phrases like organized behavior when describing Atlas. It's not a claim, it's a category, a way to say, gently and carefully, that we are witnessing consistency where natural randomness should dominate. A way to acknowledge that the object is not behaving like a typical interstellar comet, or even a typical solar system comet. A way to honor the truth that sometimes the universe presents you with patterns too beautiful and too structured to ignore. You feel that sense of beauty as you imagine each frame laid over the next. The symmetry is striking. Two opposing jets like mirrored beams, dust lanes pooling into geometric networks, a glow that holds its shape as if molded. Nothing in these images feels accidental. Nothing feels sloppy. The structure is not a single feature, but a harmony of features, each reinforcing the others. You're looking at physics that seems to prefer balance over chaos. And as you absorb that feeling, another realization settles in. Atlas shows no sign of breaking apart. With rotation this fast, with jets this strong, a normal comet should be shedding fragments. Stress fractures should appear. Bright flares should erupt as the nucleus cracks. But Atlas remains whole, smooth, intact. Whatever is driving these patterns, it's doing so with a level of stability that borders on the extraordinary. This is the moment where awe meets understanding, where you begin to grasp why researchers, commentators, and skywatchers across the world have started paying such close attention. This isn't just a bright object with interesting features. This is the first interstellar visitor to show a clear, sustained structural pattern over multiple days. This is why the world is talking, not because the object is dramatic, but because its calm, consistent, almost elegant behavior raises questions no one has answered yet. You find yourself wondering the same thing scholars are whispering to one another, sometimes reluctantly, sometimes with a spark of excitement. Is this natural self-organization? Are we watching a physical system behave in a way that nature can produce, but rarely does? Or is this something more complex? A phenomenon we haven't yet named? A process we haven't yet modeled? An arrangement of physics we haven't yet cataloged? Structure implies process, Loeb said, and tonight those 4 words feel truer than ever. A process is unfolding in Atlas. A process that produces order instead of chaos. A process that maintains stability under stress. A process that leaves clear signatures, fixed vents, intersecting dust lanes, mirrored jets, and a symmetric glow that refuses to distort. But symmetry was only the beginning. As you drift deeper into the story of 3i Atlas, something unexpected happens. Instead of feeling overwhelmed by its strangeness, you feel a kind of calm curiosity settling in, as if each new detail were another soft footstep leading you further into a place you've never been, but somehow feel ready to explore. Up to now, you've heard about symmetry, rotation, dust lanes, jets, geometry. Yet the full picture becomes even clearer when you pause and gather every anomaly into one gentle, comprehensive view. The effect isn't chaotic. It's almost meditative. A constellation of facts that, when placed together, form a shape you can finally see. Start with the first anomaly, the composition. Early spectral readings hinted that the ratio of nickel to iron in Atlas is unusually high. Most natural bodies, whether asteroids, comets, or icy fragments, follow predictable elemental patterns. Iron dominates. Nickel lingers behind, but Atlas seems to flip that balance. Nickel readings come through stronger than expected, suggesting material from an environment we don't typically encounter. It doesn't prove anything extraordinary, but it raises the first quiet, important question. Next, you consider the orbit. A retrograde path through our solar system is already rare, but Atlas approaches on a trajectory unusually aligned with the ecliptic plane, threading the planetary disk in a way that researchers estimate has about a 1 in 500 probability. Not impossible, not miraculous, simply statistically odd, as if the cosmos nudged it into a window where we could see it clearly. Then you return to the CO2 plume that first caught attention in September, a plume that pointed toward the sun instead of away from it. Natural, yes, but rarely strong, rarely persistent, rarely stable. Atlas turned that rarity into a signature. The plume didn't misbehave. It insisted on its direction day after day. By early October, the anti-tail appeared, an elegant streak of dust projecting forward, opposite the main tail, like a blade catching the faintest hints of sunlight. Anti-tails can happen, but they are fleeting. Atlas's anti-tail grew sharper, straighter, more defined as the days passed. A feature that normally fades sharpened instead. Then comes the mismatch in rotation. You heard about it already. Sequences taken minutes apart revealed changes more dramatic than those in comets spinning 20 times slower. A body rotating this quickly should be unstable. Yet Atlas rotates with clean, steady grace, as though the speed itself were part of the design. This leads naturally into the behavior of the jets. The multi-jet fixed points that erupt from stable positions, ignoring rotation entirely. No sweeping, no wobbling, no bending. Just clean, unwavering lines that behave as though anchored to an axis independent of the nucleus. A behavior that simply doesn't belong to the catalog of known cometary dynamics. Next is the brightness pulse, a rhythmic rise and fall of light that repeats gently over time. Not a perfect rhythm, but a patterned one. A whisper of structure, a nod to something periodic beneath the glow. Then you consider size. At least 5 kilometers across, thousands of times larger than Oumuamua. Large enough to withstand solar heating, but also large enough that its strange behavior becomes even more unusual. Large objects rarely maintain perfect symmetry. Atlas seems almost shaped by it, which brings you to one of the most astonishing anomalies, the persistence of symmetry. For days, the glow around Atlas held its balanced form. Most comets distort quickly as they shed dust unevenly or rotate unpredictably. Atlas stayed steady, centered, composed. Add to that the next anomaly. No fragmentation, not even a hint. Comets approaching the sun often crack, divide, or erupt into pieces. Atlas, despite its rotation, jets, and intense heating, remains whole. Whatever forces are shaping it, they aren't tearing it apart. Then you remember the wrong outgassing pattern. The fact that jets and dust lanes behave in ways that contradict the physics we normally rely on. Dust follows clean lines. Jets ignore spin. Heating doesn't shift vent locations. Each detail small on its own. Each one adding weight to the mystery. Finally, the anomaly that feels almost philosophical. The convenience of observation. Atlas's trajectory isn't just retrograde. It places the object in a sky location that allows unusually frequent imaging from Earth-based telescopes, with multiple spacecraft catching complementary angles. The odds of such perfect visibility are slim. Yet here it is, writing its story across our instruments. By now, the atmosphere around you is quiet, soft, thoughtful. The anomalies don't frighten you. They intrigue you. They settle into your mind like dots in a pattern you're slowly beginning to trace. A single anomaly is interesting. 2 anomalies are a coincidence. But 12? 12 is a different category entirely. You hear Loeb's voice in the back of your mind. 12 anomalies are a pattern, not an accident. It's not a conclusion. It's an invitation. A reminder that when nature presents you with something this layered, this consistent, this beautiful, the only responsible reaction is curiosity. How can one object be strange in so many ways, you wonder? And with that thought, you finally see why the world is paying attention. Not because Atlas screams for attention, but because it quietly refuses to fit inside our expectations. So who is watching Atlas the closest? As you follow the story of Three-Eye Atlas, you begin to notice something just as interesting as the object itself. The way different communities react to it. Scientists, space agencies, amateur observers, online groups. They all see the same images, yet each one responds in a tone shaped by their role. And when you listen closely to those tones, you begin to understand the delicate balance between caution, curiosity, excitement, and responsibility. NASA's silence is the first thing many people notice. Not absence, just silence. A careful stillness. NASA is not ignoring Atlas. They are watching it with more instruments than almost anyone else. But they are not jumping to interpretations. They are not speculating publicly. They are not placing labels on patterns that may shift as new data arrives. For a large institution, especially one so visible, silence is not avoidance. It's discipline. It is the understanding that once a statement is made, it becomes part of the global narrative. And so, NASA lets the images speak for themselves, for now. You can imagine the rooms where analysts review incoming frames. Screens glowing softly, numbers scrolling, conversations held in measured sentences. These are people trained to wait until evidence settles into clarity. Their restraint isn't frustrating, it's reassuring. It tells you that science, at its core, is patient. SETI, however, approaches the moment from a different angle. Their mission has always involved paying attention to the unusual, the unexpected, the things on the fringes of understanding. And so SETI amplifies the event, not with conclusions, but with invitation. They encourage people to observe. They host discussions. They remind the public that anomalies are opportunities for discovery. Whereas NASA holds its conclusions, SETI holds the spotlight. The contrast isn't conflict, it's complementarity. One asks you to wait, the other asks you to watch. Then there are the amateurs, the sky watchers who stand outside at 2 a.m. with tripods and tracking mounts, pointing their equipment toward a faint dot that most of the world will never notice. These are the people who captured the first clear signs of the multi-axis jets. Not the big observatories, not the major space agencies, but individuals scattered across the world, uploading their frames with timestamps, comparing patterns, arguing gently over calibration, and piecing together the earliest glimpses of Atlas's behavior. Their work matters because they fill the gaps between large missions. They capture the sky when professionals are clouded out, or when telescopes have other targets. They create a global mesh of eyes, each observing a slightly different slice of the night. In events like this, amateurs aren't just contributors, they're the front line. And then there's the public, the millions of people watching from phones and laptops, sharing images, debating interpretations, and creating a pressure that large institutions can't ignore. It's easy to think of the internet as noise, but in moments like this, it becomes something else. An engine of transparency. When hundreds of independent observers upload images within minutes of capturing them, data becomes democratized. Patterns can no longer be hidden. Curiosity becomes communal. And in a way, that's beautiful. Still, you can sense the tension. What is NASA waiting to say? What conclusions do they see but aren't ready to share? What data sits on their instruments that hasn't yet been fully processed? The silence isn't ominous. It's simply unfinished work. But you feel the question all the same. What hasn't been put into words yet? The broader picture is clear. Atlas has become a shared experience. Institutional science brings rigor. Public science brings immediacy. Amateur science brings continuity. And together, they form the most complete lens through which we have ever viewed an interstellar object. Every image, every timestamp, every analysis, each one is another layer in a collective effort to understand something that refuses to behave according to our expectations. And maybe that's the lesson. Not that Atlas is extraordinary because of its anomalies, but that the world is extraordinary in the way it gathers around them. You realize, in a quiet moment of reflection, that this is how science thrives, not in isolation, but in global curiosity. Science works best when everyone is watching the sky. The future of Atlas may depend on how we interpret these anomalies. As you sit with the growing constellation of anomalies surrounding 3i Atlas, you start to feel something shift in the way you think about the object. Up to now, everything you've heard has been observational. Images, dust lanes, symmetry, jets, rotation. But when data becomes this layered, this persistent, this quietly consistent, you reach a point where the next logical step is to ask the deeper question: what could these patterns mean? Not in a sensational way, not in the way headlines distort, but in the calm, contemplative way someone like you approaches problems that matter. Slowly, seriously, with the kind of intellectual honesty that respects what we know and acknowledges what we don't. Tonight, you explore 3 possible futures. 3 explanations that could make sense of what the sky has shown us. None of them require extraordinary claims, but all of them ask us to widen our understanding just enough to let new possibilities breathe. The first and most grounded idea is what many researchers call the natural exotic hypothesis. It suggests that Atlas may be composed of materials uncommon in our solar system. Materials formed under conditions unlike any we've modeled locally. The unusual nickel-to-iron ratio hints at a birthplace with different elemental distributions. Perhaps a colder environment where certain ices accumulate differently. Perhaps a more turbulent region of star formation where shocks create odd mineral combinations. If Atlas formed in a system with a different chemical fingerprint, then its behavior could simply be the result of those materials responding to solar heating in unfamiliar ways. Ice ratios could explain the strange jets. Exotic surface layering could account for persistent vent points. Even the symmetry might arise from a structure shaped over millions of years in a place far from our sun. Under this view, Atlas is still natural, just not familiar. Not wrong, but rare. A glimpse into geological processes that occurred somewhere else, shaped by other suns, other winds, other seasons. If this hypothesis is true, Atlas becomes a messenger carrying the story of a distant world. And that story is written not in machines or signals, but in chemistry. The second possibility carries a different tone, a quiet speculative thought that scientists approach carefully. Self-organizing structure. Not artificial, not constructed, but a phenomenon in which natural forces arrange material into stable patterns over time. Plasma physicists often talk about these behaviors. Under certain conditions, plasma organizes into filaments, braids, and stable channels. Dust can align under repeating electromagnetic patterns. Jets can follow geometric paths if the underlying field is consistent enough. Imagine Atlas not as a solid object with random vents, but as a body where internal interactions funnel energy along specific axes. Under this model, the stable jets and dust lanes aren't surprising. They're the natural result of a system reaching equilibrium. A self-organizing structure would explain the fixed vent points, the symmetry, the straight dust lines, and the jets that ignore rotation. If Atlas contains charged particles, magnetic inclusions, or stratified ice with conductive properties, It's possible that the geometry we're seeing is a natural expression of internal physics that stabilizes itself over time. This idea doesn't violate known science. It simply expands it. It suggests that certain interstellar objects may develop organized behaviors, not willful, but patterned, not designed, but emergent, a kind of cosmic self-arrangement. And if this is the truth, then Atlas becomes the first clear example of a celestial phenomenon we've never documented before. The third explanation is perhaps the most humbling: unmodeled physics. Not in a dramatic sense, but in the simplest meaning of the phrase. We may be missing something in our understanding of how objects from other systems behave. Our models for outgassing are built on comets from our own solar system. Our assumptions about dust lanes, jets, symmetry, and rotation come from bodies that share a common origin. But Atlas is not from here. It carries with it a history shaped by forces we have not fully simulated. Unmodeled physics could take many forms. Perhaps certain ices expand differently under fast rotation. Perhaps layered materials vent in periodic bursts. Perhaps the geometry of jets reflects scale effects we haven't measured at this size. Or maybe the interaction between solar radiation and exotic minerals produces feedback loops that stabilize jets instead of dispersing them. These ideas aren't strange. They're simply beyond our current range of equations. You can almost hear the tone of scientific humility settling over the moment. When faced with something that defies simple explanation, the responsible reaction isn't conclusion. It's patience. It's curiosity. It's the willingness to say, maybe we don't know everything yet. This is the heart of good science, the ability to let data lead, even when it leads into territory we haven't mapped. As Loeb often reminds his colleagues, extraordinary claims require extraordinary evidence and extraordinary data. And Atlas is, without question, producing extraordinary data. What ties these three futures together is not certainty, but possibility. They widen the path forward without forcing a single answer. They allow space for more information, more images, more nights of patient watching. And most importantly, they treat the universe not as a solved problem, but as an unfinished conversation. You feel that openness as you consider each hypothesis: natural exotic, self-organizing structure, unmodeled physics. None of them are excluded. None of them explain everything. But each one offers a way to understand what we're seeing without reaching for the dramatic. They honor the complexity, the beauty, and the quiet discipline of astronomy. And you sense, in a steady, grounded way, that Atlas is not just teaching us about itself. It's teaching us about the limits of our models, about the gaps in our assumptions, about the humility required to study a universe that still surprises us. Whatever the truth is, the next images will bring us closer. When you reach this point in the story of Three-Eye Atlas, you begin to feel something shift again. Not the quiet astonishment of new anomalies, not the deep contemplation of the possible futures, but a steady anticipation. A sense that we are standing right at the edge of a moment when the sky may give us answers. Not final answers, not complete ones, but the kind that nudge a mystery into focus. Because the next few days may be the most important in the entire observation campaign. NASA is preparing to release a new batch of multi-spectrum data, images and measurements drawn not just from visible light, but from infrared instruments, ultraviolet sensors, and spectrometers spread across multiple missions. These tools don't just capture what the object looks like. They reveal what it's made of, how its heat moves, how its jets behave at wavelengths our eyes can't see, and how its rotation modulates the material streaming from its surface. Multi-spectrum data has the power to transform an image into an explanation. One of the first measurements scientists are waiting for is a refined rotation curve. If the rotation truly completes in minutes rather than hours, that single detail could eliminate several of the simpler outgassing models. A fast rotation means forces are acting differently on Atlas's surface than they do on ordinary comets. If the curve matches the brightness pulse pattern, then symmetry becomes even more meaningful. Not a coincidence, but a consistent signature of a process we can start to map. Then comes the compositional spectrum. This is where light becomes chemistry. By breaking the object's glow into its constituent wavelengths, NASA's instruments can identify which materials are present in each jet. If the red forward jet contains different ices or metals than the blue backward jet, it could support the natural exotic hypothesis. If the ratios between elements look nothing like solar system comets, it may hint at a completely different evolutionary history. And if both jets contain the same elements despite their different colors, that would point toward interactions not driven by composition, but by physics. Jet geometry is the third key. Multi-angle observations over the next week will allow researchers to determine whether the jets truly emerge from fixed vent points, or whether the stability we see is the result of projection effects. If the geometry is locked in place, even when seen from different vantage points, then the self-organizing structure hypothesis gains strength. If, on the other hand, the jets shift slightly under new angles, it may soften the case for internal organization and bring the discussion back toward unmodeled outgassing mechanics. Each kind of data, rotation, composition, geometry, has the potential to trim away one hypothesis at a time, not in dramatic leaps, but in careful, patient steps. This is how science narrows a mystery, not by collapsing possibilities, but by refining them. Each measurement becomes a clue. Each clue becomes a boundary, and each boundary reshapes the landscape of what remains possible. You feel the quiet hope that comes from knowing we might be days away from the first real hints about what Atlas truly is. Not the full picture. Nothing in astronomy arrives so quickly, but a more grounded understanding, a sense of direction, a clearer path through the unknown. What makes this moment powerful is not the promise of a revelation, but the fact that after months of watching, the universe is finally giving us the kind of data that can speak directly. And yet, even as you wait for the next release of images, spectra, and measurements, you're reminded of something deeper. The universe rarely gives only answers. Often, it gives perspectives, moments of stillness, chances to wonder. It asks you to hold uncertainty with grace, to let the sky unfold at its own pace. But answers are not the only things the universe gives us. There comes a moment in every long night of watching the sky when the need for answers softens. You begin the evening curious, alert, wanting to understand every detail of what you see. But as the hours stretch on and the darkness settles deeper around you, something else takes over. A quietness, a gentleness, a sense that the unknown is not a problem to solve, but a space to rest in. With 3-eye Atlas, that feeling arrives naturally. After all the anomalies, the patterns, the geometry, the questions, we return to something deeper, the simple beauty of not knowing. There is a kind of solace in mystery. You feel it when you stand beneath the night sky and look up at stars that have traveled hundreds or thousands of years just to reach you. Nothing is rushed out there. Nothing demands immediate clarity. Even the objects we understand best, planets, moons, the familiar comets of our own system, carry shadows of uncertainty. Atlas simply reminds us of that truth in a more vivid way. Its behavior is strange, yes. Its structure is unusual, but its presence is peaceful, silent, patient. A traveler that has crossed unimaginable distances to pass through our corner of the cosmos. When you imagine astronomers staying awake late into the night, adjusting their instruments, refreshing their data feeds, you realize that the experience is not unlike your own. They're not chasing answers in a frenzy. They're participating in a slow, thoughtful conversation with the universe. A conversation that has been unfolding for centuries, one observation at a time, one mystery at a time. Science, at its best, is not a race. It's a long, steady walk. A discipline built on patience, humility, and the willingness to be surprised. And in that way, Atlas becomes more than an object of interest. It becomes a reminder of why you look up in the first place. The night sky has always offered a kind of refuge, the soft hum of distant starlight, the calming idea that while life on Earth changes moment by moment, the vastness above holds steady. Observing something like Atlas reconnects you to that quiet rhythm. It invites you to slow down, breathe, and let the unknown be a companion rather than a challenge. You picture yourself outside under the cool air, listening to the faint rustle of leaves or the distant hum of a city settling down for the night. You lift your gaze toward a point of light, a point you now know contains more questions than answers, and somehow that makes it easier to rest. There's comfort in the idea that the universe is not finished, that it's still revealing small fragments of itself, still offering moments where we can feel wonder, still reminding us that mystery is not the opposite of knowledge. It's the beginning of it. Atlas also teaches us something about ourselves. The way we react to the unknown says more about our nature than the anomaly does. Some people rush to conclusions. Some grow anxious. Others lean in gently, trusting that clarity will come when it's ready. And maybe that's part of what this object brings to us, a chance to practice patience, to remember that understanding does not always arrive on demand, to appreciate the rare opportunity to simply observe without needing to define. The universe has never been in a hurry. Stars take billions of years to evolve. Galaxies drift across cosmic distances so slowly that an entire human lifetime won't shift their shapes by even a fraction of a percent. Light itself takes time, traveling across empty space for ages before reaching our eyes. When you place yourself within that scale, the unknown stops feeling threatening. It becomes spacious, soothing, a reminder that you are part of something vast and ancient and unfolding. And now, as you reflect on everything you've heard tonight, the anomalies, the theories, the possibilities, you might feel a sense of peace rising beneath the curiosity. You don't need all the answers tonight. You don't need certainty to fall asleep. You just need the gentle awareness that the story continues. that the universe is in motion, that tomorrow's images may bring something new, and that tonight you are allowed to rest in the space between questions. What might this object teach us about ourselves? It's a small question, but it lingers. Maybe Atlas is reminding us to look more closely. Maybe it's reminding us to stay open. Maybe it's whispering that even in a world full of information, the unknown still has value, still holds beauty, still gives us room to feel wonder. And so, as Atlas drifts farther, and now, as the last threads of tonight's story settle around you, Atlas drifts farther into the deepening dark. The glow you followed for so many nights softens at the edges, no longer sharp, no longer defined, just a faint shimmer dissolving into the background of space. What once seemed so urgent now feels gentle, distant, almost like a memory forming in real time. The object continues its long journey, carrying its questions with it, unbothered by whether we answer them tonight or years from now. Out there, beyond the reach of our atmosphere, everything slows, everything loosens, everything becomes quiet. You can imagine the solar wind brushing past Atlas as it moves on, scattering dust into soft trails that fade the farther they stretch. The jets that once cut the darkness with clean precision now blur into the vastness, merging with the interplanetary breeze. The sun's warmth weakens as the object glides outward, and the radiant pressure that shaped its glow begins to relax. In that relaxation, the last hints of its symmetrical halo thin into the cold silence between worlds. What remains is only the dimmest whisper of light, just enough to remind you where it once was. Far closer to home, the night deepens. The large observatories that captured so many of the images you've heard about begin shutting down their systems. Screens dim, instruments cool, domes rotate into their resting positions. The hum of machinery softens to a faint, low murmur. Doors close with gentle clicks. Technicians gather their notebooks, log their final entries, and step outside into the crisp air. For a moment, they look up at the same sky you see, the same stars, the same quiet. And then they drive home through sleeping towns, leaving the night to tend its own mysteries. Even the air around you seems calmer now. Whether you're listening from your room, your car, your porch, or somewhere in between, the world around you holds steady. No rushing, no pressure, no need to understand everything at once. The earth turns slowly beneath your feet, wrapped in its familiar blanket of atmosphere, carrying you through the darkness with the same steady patience it has always offered. You are safe here, held, grounded, part of something vast, but also gently predictable. As your breath slows, you feel how naturally your mind begins to settle. The details of Atlas, the jets, the symmetry, the dust lanes, the questions, begin to soften just like the glow of the object itself. They drift outward, becoming lighter, less sharp. You don't have to analyze them now. You don't have to reach for conclusions. The universe isn't asking anything of you. It never was. It simply offered you a moment of wonder before sleep, a chance to feel the quiet immensity of a sky that has room for both knowledge and rest. That's the beauty of nights like this. The unknown doesn't press on you. It surrounds you gently, like a soft horizon stretching out in every direction. Atlas may carry questions, but tonight those questions can stay where they are, floating through space, waiting for the right time to unfold. You don't need to solve anything before you close your eyes. You don't need to hold the entire story in your mind. Let the universe keep its mysteries for now. It's been doing that for billions of years. It can hold them a little longer until you're ready again. And maybe you find comfort in that, in the idea that discovery doesn't depend on constant vigilance, that the cosmos will still be there in the morning, that nothing important is slipping away, that the next time you look up, Atlas will have traveled a little farther, but still be part of the same wide tapestry of stars. You may wonder, softly and without urgency, what will we discover next time? The question feels light, open, inviting. A promise you don't need to chase tonight. Because the truth is simple and soothing. The universe doesn't need you to know everything tonight. It only needs you to rest, to breathe, to let your thoughts drift the way Atlas drifts, calmly, steadily, peacefully, into the quiet spaces where sleep begins. So, let the night settle fully now. Let the room dim. Let your shoulders loosen. Let the last of the day fall away as this story fades into silence. Good night, traveler.